the subject of today's podcast. I've been wanting to do an episode on climate change for a while, and the podcast I did with Scott Adams just reminded me of the need. There is so much confusion and misinformation out there, and it is hugely consequential. Since I recorded this podcast, President Trump has nominated a climate science denier to run NASA. This is a Republican congressman without any scientific background who once stood on the floor of the House and demanded that President Obama apologize for having funded climate change research. Trump has appointed him to run NASA. Think about that as you listen to this podcast. Anyway, I found a really good guest to walk us through the issue. My guest today is Joseph Romm. Joe is one of the country's most influential communicators on climate science and solutions. He was chief science advisor for the show Years of Living Dangerously, which won the 2014 Emmy Award for Outstanding Nonfiction Series. He is the founding editor of Climate Progress, which Tom Friedman of the New York Times called the indispensable blog. In 2009, Time named him one of the heroes of the environment, and Rolling Stone put him on its list of 100 people who are, quote, reinventing America. Romm was acting Assistant Secretary of Energy in 1997, and he's a fellow at American Progress and holds a PhD in physics from MIT. And perhaps most relevant, he is the author of Climate Change, What Everyone Needs to Know, put out by Oxford University Press. And it is a very handy, accessible, comprehensive book that is organized in Q&A format. So every question you have ever had or heard posed, skeptical or otherwise, about climate change seems to be answered in this book. And Joe and I get into many of the details. We talk about how we know the climate is changing and how we know that human behavior is the primary cause. We talk about feedback mechanisms that increase the problem of global warming and why small changes in temperature matter so much. We talk about the threats of sea level rise and desertification and the best and worst case scenarios given where we currently are. We talk about the much maligned Paris Climate Agreement and the politics surrounding climate science. As always, if you're finding this podcast valuable, you can support it at samharris.org/support. And around 1 to 2% of listeners regularly support the show at this point. If you are one of these, I want to thank you. And as I've said before, if it's a stretch for you to support the show, then you shouldn't do it. If you can't walk into a Starbucks and buy a fancy cup of coffee whenever you want, then please don't buy me one either. That's why the show is free, and it makes me very happy that it's free and that everyone can listen to it, regardless of their circumstance. But if you are doing okay financially, and you want to consider this show like an extra cup of coffee, well then your support is hugely appreciated, and you are actually making it possible for me to do this work on a regular basis. And now, without further delay, I bring you Joe Romm. I am here with Joe Romm. Joe, thanks for coming on the podcast.
Thanks for having me, Sam.
We're going to talk about climate change, which, as you know, is a big and important topic, and we will talk about what we know about it, what we don't know about it, and I suppose what many people refuse to know about it. But first, before we jump in, can you describe your background scientifically and in policy circles and just the work you've done on this issue?
Sure. Well, I have a PhD in physics from MIT, and I spent a year on Capitol Hill as a Congressional Science Fellow, and then I went to work at the Rockefeller Foundation for a couple of years, looking at issues like the environment and national security and energy. Then I worked with Amory Lovins for a couple of years, the father of energy efficiency, really a great guy. And then 5 years at the U.S. Department of Energy during the Clinton administration, where I ended up acting Assistant Secretary for Energy Efficiency and Renewable Energy, which is the $1 billion office that does all the clean energy research, development, demonstration programs for the federal government. And then I left to do a lot of consulting with companies on how to reduce greenhouse gas emissions and how to use efficiency and renewables. And then August 29, 2005, Hurricane Katrina destroyed my brother's home. He lives in Pass Christian, Mississippi, and uh, a mile inland there was 20-foot storm surge, and the inside of the house looked like a washing machine. He asked me if he should rebuild his home, and I started talking to climate scientists and hurricane experts, and reading the literature and going to conferences, and that's when I realized that two things: climate change was a lot more dire than I realized, and that scientists weren't doing a very good job of communicating it. And since I had been raised by newspaper people, my father was a newspaper editor, uh, I decided to stop doing clean energy consulting and just do writing and communications on climate change. And I was able to get a position at the Center for American Progress, which had recently started and launched its Think Progress website, which is one of the most widely read progressive news websites in the world. And that was about 11 years ago. 11 years ago next week, I launched climateprogress.org, which was grew over time into a we now have a staff of 5 or 6 reporters. It's part of the larger Think Progress enterprise. If you go to Think Progress, you'll see articles by me and other people on clean energy and climate change. And it's probably the most widely read climate website in the world. And that's what I've been doing for 11 years. Also worked with the Years of Living Dangerously TV series. Some of you may have seen on Showtime a few years ago, or last year on National Geographic Channel. That's the James Cameron, Arnold Schwarzenegger uh, series, Emmy-winning series that documents what's going on climate change, what the solutions are, and so that's what I've been doing. I'm very fortunate to be able to keep track of climate change and clean energy and write about it and speak about it.
Yeah, and you've written this very lucid book that's right on point, titled Climate Change: What Everyone Needs to Know, published by Oxford University Press, which is not actually known for publishing propaganda. And yeah, if I'm not mistaken, your PhD in physics from MIT was not focused in some totally unrelated area. Didn't you have some focus on oceanography?
It did focus on oceanography. Yeah, I was fortunate. I was able to do my PhD thesis with a man named Kostas Tsipras, who back in the day, wrote a great number of Scientific American pieces, particularly on arms control issues. And he allowed me to do my thesis research at the Scripps Institution of Oceanography with Walter Monk, one of the world's greatest oceanographers, and actually did my thesis. Wasn't on climate change at all, but the thesis itself was an analysis of data from the Greenland Sea, and just being at Scripps and attending seminars by some of the world's greatest oceanographers, I couldn't help but also learn at the time. This was the mid 1980s, before a lot of people were talking about climate change. They were talking about climate change, so that was a true education.
Right, right. So before we jump into the details here, I should say that my goal in this conversation is to dispel the most consequential forms of confusion on this topic. And so I went out on Twitter when I knew we were going to do this interview, and I announced that I'd be doing a podcast on climate change, and I asked people to post questions, and I got over 1,000 responses. So there's no shortage of questions here. But let's start with the basic picture of what's going on. And I want to get into the weeds, but I don't want us to assume that people know much of anything about this issue because despite its enormous importance, most people, certainly many people, don't. So, first, what is the difference between climate and weather?
Well, climate, they say, is what you expect, and weather is what you get. So weather is highly variable day to day. Is it going to be cloudy? Is it going to rain? Is it going to be a very hot day? Is it going to be a coolish day? That's the weather. But of course, on a given day, whether it's warm or cold is relative to what the underlying climate is. A hot day in the summer is obviously quite different than a hot day in the winter. So, weather forecasting is obviously tricky, hard to do more than a week, 10 days in advance. But climate is the statistical aggregation of all the weather. So, climate tells you it's going to be warmer in the summer. Climate tells you the Greenland is going to be colder than the Sahara Desert, and the Sahara Desert is going to be drier. So the long term trends in your local climate are very slow moving, and one of the points that I make in the book and on the website is that since we came out of the last ice age 11,000 years ago, the Earth's climate has been very stable. I mean, the temperature has really varied, over maybe half a degree Fahrenheit plus or minus. And that stable climate is what allowed people to settle in cities. They had reliable, the weather wasn't constantly changing. They knew what the rainfall would be, they knew what sea levels would be. People, therefore, could have large scale agriculture, and that led to cities, and that has, sustained now a population of over 8 billion people. But because we have been pouring vast amounts of these heat trapping greenhouse gases into the atmosphere, we have seen a rapid rise in temperature, particularly over the last century or so. And in fact, the temperature uh, of the Earth, driven by greenhouse gases, driven by burning fossil fuels, coal, oil, and gas, and releasing carbon dioxide, that temperature change has been 50 times faster than the very slow changes in the past 5,000 years. And it is both the amount of change and the speed that's worrisome, because the faster it changes, the harder it is to adapt to. And the more it changes, of course, the more dramatic the impacts are.
We've already closed the door to one source of skepticism here about climate change because most people understand that it's impossible to predict the weather far in advance. And from that, they conclude that it must be hard to say anything about the climate far in the future. In fact, we got one of these on Twitter. One person wrote, most forecasts can't accurately predict the weather more than 5 days in advance. How can you have it right for 5 years or 5 decades ahead? So we spared one person some fatal embarrassment.
And I think that is a very important point worth driving home. I can't tell you in 1 year whether you're going to have, a 100-degree Fahrenheit day or a 60-degree Fahrenheit day. But I do know what the average yearly temperature is, and if you look at the average yearly temperature of the globe, or even the average monthly temperature, that doesn't change very much over time. Unless, of course, something is forcing it to change. That's the key point. We're forcing the change, and that's why year by year we've been seeing these hotter and hotter years.
Okay, so tell me how we know that we are forcing this change. There's two parts here. How we know that the climate is changing, i.e., heating up, and how we know that humanity is playing a role in changing it. And for this part, I'd really like you to limit yourself to what is totally uncontroversial from a scientific point of view. And we can get into gray areas later, but is there a version of this story that is at the level of smoking is harmful to your health? Can we make it that uncontroversial?
Sure, although that still won't make it uncontroversial in the sense that, as you know, the tobacco companies launched a major disinformation campaign to confuse the public for decades about the science of smoking and the health consequences. And so, decades after the medical community, was quite certain that smoking was bad for your health, that myth persisted. But it is true, and in recent years, the scientific community has said that our certainty that the climate is changing, that humans are the primary cause, our certainty level is exactly comparable to our certainty level that cigarette smoking is bad for your health. So they are comparable. One thing I want to say right away, and I'll probably repeat, anybody who wants to know the underlying science of these myths and the debunking of them, there's a website, a great website, which just had its 10th year anniversary, called Skeptical Science, and it literally goes through each of these, and you can click on links to the actual scientific literature depending on how informed you want to get. So fundamentally, if you look over the history of the Earth, whenever the climate changes substantially, it's because it was forced to by some external change. Often that change was a slow change in the Earth's orbit, reducing the amount of sunlight that hit, particularly the northern hemisphere, and that led to the ice age cycle. Over the past million plus years. Um, but those ice ages and the end of those ice ages, as it turns out, were triggered by the changes in the Earth's orbit. But those changes then actually led to a feedback, which is release of greenhouse gases and other feedback. So we have known literally for two centuries that there are certain gases that trap heat in the atmosphere, and that the major one that we control is carbon dioxide, and that it was predicted for over a century that if you keep burning, the fossil fuels that had been tracked in the ground, in the form of coal, oil, and gas, if you keep burning those, you are going to be basically putting more and more blankets around the Earth. You're going to be heating up the Earth, and that heating up is going to have a whole bunch of consequences. As to the question of how do we know that humans are the major cause, the answer is twofold. One, you can look at all of the potential sources of heating and cooling, and you find, particularly in recent decades, that all of the ones that aren't human caused would actually be cooling the Earth, because the sun's solar radiation has actually declined slightly in recent decades. We've had volcanoes; they're another cooler, because they put in aerosols that block the sun. So if you take uh, if you take away all of the so-called natural cycles and natural things that change the climate, you would find that the vast majority of warming in since the middle last century is due to human activity, principally the release of these heat trapping gases. And in fact, not only did the scientific community conclude in its most recent assessment, every 5 years, all the world's leading scientists review all the scientific literature and they issue reports to the world government. Those are the Intergovernmental Panel on Climate Change. And those reports, by the way, are literally argued over line by line by all of the governments of the world. So they end up as a least common denominator. And those studies, the most recent ones, concluded two things. There is a 95 to 100% chance that most of the recent warming is due to humans, and at the same time, the best estimate for how much of recent warming is due to humans is all of it, 100%. So the peak in the most likely scenario is that humans are responsible for all of the warming since 1950. But like you envision a Gauss, a curve, like a bell curve, there are small chances that all humans are only responsible for, let's say, 75%. But, there's no point in getting into a lot of detail on that because this is not a subject of much debate at all in the scientific community.
I'm actually wondering whether it's relevant in the end. So there are at least three parts to this story. There's the fact that the planet has been warming over the last century. There's the fact, or at least the claim, that human behavior has contributed to it, either in part or in entirety. And then there's the claim that warming past a certain point would be catastrophic for us. And we will definitely get into that. But this third claim, in my view, seems to undercut the significance of the second. I mean, if warming past a certain point is going to be catastrophic for us, it doesn't much matter who caused it, right? Or what the cause is. We'd want to find some way of mitigating this warming, arresting it and mitigating it anyway, right?
Well, I don't entirely agree with that in the following sense. Knowing that humans are the major cause tells us we are the major solution. If this were just an underlying natural change, like the incredibly slow changes in and out of the ice ages, then there's not much we could do. I mean, we could adapt, we could plan for the changes, but we couldn't stop the changes. The fact that we know that we are, essentially all of the cause of recent warming tells us that if we were to change, replace fossil fuel combustion with, clean energy, renewables, and the like, that we would slow and ultimately stop the amount of warming. And so that's sort of point one. Point two.
Joe, let me just jump in there. I totally agree with that in that it points to a way forward toward a solution. But given the predicted consequences here, a sudden warming, not a gradual warming, would be bad for us, whether or not we're the cause. And if there's any way to mitigate it, we would be interested in doing that. I guess what I'm trying to do here is differentiate the problem as we face it from a kind of common attitude you find among people, which is just a matter of disapproving of human caused change in principle, analogous to thinking that it was a bad thing that we wiped out the dodo bird. There's a kind of a sentimentality for nature that I don't want us to be confused by. I'm not saying I don't share it, but that's not really the issue. The issue is if the average temperature of the planet keeps going up and we hit the most dire projections, whatever the cause, we have a huge problem that for which we should be seeking a solution.
Right, but let me, if one thing I can get out of this discussion with you is to persuade you that the phrase "whatever the cause" is really a phrase that concedes the battle, and it is false. It's wrong. It isn't whatever the cause. If we didn't know the cause, then we wouldn't know that warming is not only going to continue; it's going to speed up. Right. We're not, this is science. We put 12 men on the moon and we got them back. We don't make guesses. And the scientific community as a whole doesn't come out and say, you know, on our current path of burning fossil fuels, we are headed towards rates of warming that will have catastrophic impacts. If you took away the cause, then you'd be able to make no statements about the future. What, at the end of the day, what science is an ability to make testable predictions. And if your predictions don't come true, your theory is wrong. And if they do come true, then you have growing confidence in that theory. So no, I don't use the phrase "whatever the cause" because we know the cause, and that's how we know what's going to happen. And that's why we know it's going to happen literally, thousands of times faster than whenever the climate changed, because of purely, orbital or natural changes. And we are, in fact, acidifying the oceans, more than 10 times faster than ever happened before under, previous dating back millions and millions of years. But can I make one other point, which I'm
Sure.
not going to go into, but
Yeah.
you can read my book. There are also the type of warming that we're getting is also the exact type of warming that you would expect if it were due to greenhouse gases. And I go through that in the book. The fact that the lower troposphere, the air near where we are is warming quickly, but in fact, if you go high enough in the atmosphere to the stratosphere, it's actually cooling. But it's only cooling there because the warming is caused by a heat trapping layer lower than that. So, I don't. The point is, I don't want to get technical, but one of the reasons that scientists have so much confidence that humans are the cause is the theory predicted that greenhouse gases would cause the warming. The type of warming is the kind of warming that you would have expected from greenhouse gases, and all of the other things that cause warming, aren't moving in the direction of cause warming. And again, the type of warming we're getting is not the type of warming they would cause. That's why you get these incredibly strong statements that we know humans are the primary, indeed almost entirely, the cause of recent warming.
Well, Joe, those are exactly the kinds of technical details I want you to bring forward because, as you know, in the absence of a statement of the sort you just made, skeptics take the fact that part of the atmosphere is warming and part is cooling as a sign of the ambiguity of the situation. Even a coarser grained source of confusion, true or feigned on the part of skeptics, is the fact that what is predicted in terms of the results of global warming entails both conditions of drought but also increased flooding. And so now you have a climate change skeptic laughing over the imponderable fact there that, well, what is this, some sort of scientific koan where you're telling me we're going to have a drought and lots of flooding? So it's good for you to make sense of all of that as we move forward. Before we get into the details of what's predicted, what are some of the feedback mechanisms that cause this to get out of hand in ways that may be counterintuitive, so that where an initial warming can become far more substantial?
Well, one of the best known feedbacks is the loss of ice on land and the ocean, particularly the Arctic Ocean. So, what happens is that as the planet warms up, of course, ice melts. Now, ice is highly reflective. So, if the ice is on the land, then as the ice retreats, you're exposing the land, which is dark, and therefore, whereas ice might reflect 90, 95% of the light that hits it, the ground absorbs most of the light. So you're actually, as the ice retreats, the earth is actually absorbing more of the sun's heat, and therefore it heats up faster, and therefore the ice retreats more. And so that is one of the best known feedback effects, and that is occurring both on land and as we get the reports year by year, the Arctic Ocean, the Arctic ice cover, particularly during the summer, is retreating rapidly. And again, when you replace ice covered ocean with the blue wavy ocean, you get the ocean absorbing considerably more of the sun's energy than it was when it had a nice insulation blanket, if you will, from the ice. Uh, so that's a classic. That's called a fast feedback, and that is one of the best known, and we're clearly witnessing it now. It's one reason, by the way, that the warming is occurring twice as fast in the Arctic as it is in the rest of the globe.
And then, now there's also a feedback mechanism with respect to water vapor, right?
Yes, that's another fast feedback. So water vapor is a heat trapping gas. It is so when you start the initial process of warming through injecting a large amount of greenhouse gases or changing the Earth's orbit, then you start to evaporate more water as you warm up the planet, and that water goes into the atmosphere and it also traps heat. So that is a feedback too, yes, and that is another major fast feedback.
I think I've seen that fact in isolation seized upon by skeptics as a sign of just how preposterous the situation is as described by science.
Yes, and again, this is the kind of thing. If skeptical science will go into details. If anyone is interested, that most of the warming is due to the water vapor. But the excess water vapor is there because of the excess carbon pollution. By the way, it should be said, people should understand that the greenhouse effect is not controversial in the least. If you took that, we have an atmosphere. That's why we have a habitable planet. That's why we're not Mars, right? If you took away the entire atmosphere, the carbon dioxide, the water vapor, everything that traps heat, the planet would be 60 degrees Fahrenheit colder. So there would not be a lot of places that would be very hospitable for life.
I mean, one problem here strikes me is that the changes in temperature that people are worried about don't seem so great. When you look at your thermometer or you judge the weather for yourself on any given day, when you hear about a 2-degree rise Celsius, like 3.6 degrees Fahrenheit, or a 4-degree rise, or even in the worst case, an 8-degree rise. I mean, if you told me, 30 years from now, my children will be living in a world that is on average 4 degrees Celsius warmer, it's not immediately obvious why that would be a big deal. If you don't like the heat, you just move further north, right? Canada is going to be great. What are the likely effects of these changes in temperature as we go up in increments of 2, 4, and 6 degrees Celsius?
Well, I think this is a very good point. First of all, obviously, the rest of the world talks Celsius, and whereas Americans have, in their mind, their temperature gradations are based on Fahrenheit. So I think it is better to talk about Fahrenheit. It's still a small number. 3.6 degree Fahrenheit um, is indeed widely viewed in the scientific community and by essentially all the major governments in the world, except our current one, as a threshold beyond which climate impacts move from being dangerous to being catastrophic at a very rapid rate. Now, you can look at it a couple of different ways. One of which is that the average temperature going up pushes the extremes up much faster. And I have a chart in the book that shows that if you can visualize a bell curve in your head, where at the very right side is that tail where you get the monster heat waves that really are devastating to people in agriculture, or the monster droughts, or the monster superstorms. They are a teeny fraction of the area under the bell curve. But if you now visualize that bell curve shifting a couple of degrees to the right, all of a sudden, what had been very infrequent events all of a sudden start to become quite frequent. And that's why you hear that, like a superstorm Sandy, which might be a once in a thousand year storm, is now actually under a once in a century storm. And in fact, Sandy followed Hurricane Irene, which was also at the time a once in a century storm. And so you see, you can't, storms that used to be once in a century, once in 500 years, if they're now coming every few years, it's because we've changed at the high end of the far end of the bell curve, the frequency of the really rare events. And historically, it has been the really rare events that have done most of the devastation. In the history of hurricanes, it has literally been 7 or 8 or 9 hurricanes that have done half of the damage. Katrina and Sandy, these are the two most destructive storms. And so they're outliers. So part one, the reason we worry about this is we're very concerned about the outlier events because they're the true catastrophes. Secondly, when you look at, let's say, Superstorm Sandy, one of the things that warming changes is sea levels. And as you raise sea levels, every storm that you see is going to have a storm surge, which is higher and higher because it's the underlying average sea level keeps going up. So, you get that impact of whatever the weather was going to be. Now you have global warming on top of it. That's why, for instance, El Nino years, which are years that have freaky weather and are slightly warmer than usual, they tend to be the hottest years on record because the small amount of the extra regional warming from the El Nino is put on top of the global warming trend. Now, we've had 2014 was the hottest year on record, and then 2015 beat that easily to become the hottest year on record, and then 2016 beat that. So we've been seeing unprecedented records in warming, and 2017 is on track to probably be the second warmest year on record, but the hottest year on record without an El Nino. So we're starting to see, the point is, we're starting to see levels of warming that you normally only see during extreme years be the normal weather. And so that's where, and that's, in other words, the climate is changing. And that's what I try to tell people, for instance, when I talk about drought. You can look at the California drought, which lasted 5-6 years, and that was the worst drought in 1,000 years. But the point is that as you make the average rainfall a little less and the average temperature higher, then suddenly that type of drought becomes a 10-year drought or a 20-year drought. And instead of it happening every 100 years, it happens every 10 years. So that is one, obvious thing that is why even small temperature changes can have a big impact. Just by the way, I mean, another analogy people use is, if you imagine the planet to be like a human being, it's designed, we spent 10,000 years at a relatively constant set of weather patterns over time. The climate didn't change very much. Billions of people have chosen where to live based on their knowledge of, is it too warm here? No. Is there enough rainfall to sustain life? Yes. Is the sea level endangering us? No. So the point is, we've literally 8 billion people are living in places that they chose to live based on a relatively stable climate. You now add a few degrees to that, and it's literally like adding a few degrees Celsius, or twice that Fahrenheit, 5 degrees, let's say Fahrenheit, to your body temperature. So our entire body temperature is constructed around 98.6, and we have mechanisms in our body, as I'm sure you know, to regulate that temperature. And if you start going outside of that bounds, it means something is wrong. And if it stays outside that bound for a long period of time, it has dire consequences. Well, the same is true for the climate. If the planet warmed 2 degrees and stopped, then we would adjust to that. But that still doesn't mean that the 8 billion people who live where they do now wouldn't have to move. A billion or 2 billion people moving, this is a catastrophe, right? I mean, we saw what 2 or 3 million refugees from Syria turned global politics upside down.
Well, let's talk about that for a second. The why people would need to move. I guess 2 obvious reasons come to mind. You're talking about sea level change, so the inundation of certain coastal areas, and you're talking about the dust bowlification of certain areas where we depend upon agriculture to be viable. Perhaps there are other reasons that I haven't thought of. Tell me about certainly those 2 variables and anything else relevant to deranging global politics.
Sure. Well, people talk a lot about different impacts. So certainly I would, if your listeners come away from anything, I would want them to think in terms of the 2 most worrisome impacts. Is yes, dust bowlification, turning an area that was, let's say, semi-arid but could grow crops and sustain life into something that's purely arid. ultimately a desert. But in the transition from it being semi-arid or near semi-arid to becoming a desert, it's just going to get drier and hotter, and droughts are going to last longer and longer. And we know that again, we have designed an agricultural system of the world in which we feed large amounts of the world from relatively small tracts of land. I mean, we have two bread baskets in this country, the Midwest extending to the Great Plains and California. Even though, of course, Southern California is essentially a semi arid, near desert climate. Um, so, again, if you just shift the climate zones a little bit, all of a sudden you find that your bread baskets are getting these mega droughts on a regular basis, and many of our crops are quite temperature sensitive. People want to Google, corn and temperature sensitivity. They will learn, a great deal about it. So the point is that yes, much of our population is fed by an agricultural system that truly wants a stable climate. You talk to a farmer, the thing that causes the most problems, obviously, is extreme weather variability. Too much rain, too little rain. It's too hot or it's too cold. So that's an enormous problem. Literally, there are lots of people living in places where they're not going to have sources of food. And by the way, this is also related to sea level rise, because many of our richest agricultural areas are deltas, right? The Nile Delta, and the low-lying areas of Bangladesh and Southeast Asia. So you raise sea levels a couple of feet, and suddenly the mini rich deltas that were feeding hundreds of millions of people, they are flooded, and of course they're flooded with salt water. And that saltwater intrusion, by the way, is already happening. As sea levels rise, salt water goes further and further up those deltas. And, if you Google saltwater intrusion, you will find that is a mammoth problem already for places like Egypt and Bangladesh and the water systems of Miami. So part one is, are you going to be able to feed? I mean, we're going to have 10 billion people in mid-century, and I wrote an article for Nature on dust bowlification. It's titled "The Next Dust Bowl," saying the biggest threat facing humanity is how are we going to feed 10 billion people when we're moving in a rapidly changing climate to a world that has less potable water, less arable land, and much more intensive droughts and superstorms. So, that is problem number one for billions of people and the choices that they've made where they live now. The second is sea level rise. People, most of the population of the world, or half the population of the world, lives within, 50 miles of the ocean. People like to be near water. Water has made trade possible. Most of your major cities are near waterways, near the ocean, historically, and even today. So we have, billions of people, and so we have hundreds of millions of people who live right on the ocean, and in places like Bangladesh, and even places like, Miami and Louisiana and Norfolk, Virginia, or even Los Angeles. We have staggering amounts of people who live where they live because sea levels have been, until recent decades, pretty damn stable. And we're now moving to a situation where we are where the worst case scenarios of sea level rise appear to be the ones that we are facing. And if you were to have a leading expert, a glaciologist, expert on Greenland or Antarctica, they would tell you that the great ice sheets are melting much faster than anyone thought, and that we may be much closer to tipping points beyond which we can't stop them. And Therefore, we look to be headed to what used to be the worst case levels of sea level rise are now pretty much the business as usual projections. I'm talking about 3, 4, and 5 feet. Um, and if you can go online and find programs that allow you to look at the coast of the world, coast of different cities under 3, 4, or 5 feet. But I can tell you that all of South Florida, if you've been there, you know how flat and low lying it is. It's simply not possible that South Florida is habitable by the end of the century under those scenarios. But the same is true of Bangladesh, and the same is true of lots of places in this country and lots of places around the world. So again, we are talking about places where hundreds of millions of people live are simply going to be either underwater or they're just going to be routinely drenched in storm surges. I mean, after all, you don't, we don't live in places that are, routinely dumped by storm surges, but all the storm surges are on top of the sea level rise. So we don't, no one lives, I didn't say no one, but we don't live right at sea level rise, right? Because you have the tides and you have storm surges. So, yes, the kind of withdrawal that is starting to happen, is going to be sped up. And so we are going to end up with 100 Syrias worth of failed states, inundated areas, and refugees. That's where we're headed towards, and that's of course why the Pentagon is incredibly concerned about climate change, and the Pentagon has been issuing report after report saying, you guys, climate change is going to become a major driver of civil conflict as people fight for scarce fresh water, as people are forced out of their homes and to move to another place where people who are already there may not be quite so welcoming. And I point out, I've written many times, let's just look at our southern border. One of the predictions of climate science is places that are semi-arid are going to dry out and get hotter, and therefore they are the ones that will turn into desert the most. Well, the semi-arid region of this country is the Southwest, but that region extends down to Mexico, straight into Central America, of where there's over 200 million people living now, and their populations are highly concentrated either on the coasts or in agricultural areas. Now, if you dry out their agricultural areas and flood their coasts, you're talking about tens of millions of people who are living in places now that will not be habitable, in the second half of the century. They're not going to want to head south. They're not going to head out to the coast. They'd like to head north. And we certainly know how welcoming the United States is to refugees from the South. And I don't, I'm saying that slightly sarcastically, obviously.
Don't you understand, Joe? We will be heading north to Canada, so we'll be on the same team at that point.
Well, and of course, and one point is worth making, of course. One of the reasons why the world works the way it does is because our richest agricultural areas, they're in the mid latitudes where you get a lot of sun, right? You can't grow these amount of crops up in northern Canada or in Siberia. You can grow some crops there if it warms up enough. But remember, 6 months of the year, right? You don't have a lot of sunlight in those places. So it isn't just, agricultural areas are going to move north. I mean, after all, by the way, we have highways and we have mega cities and mega forests. So the notion that you just shift everybody north of 1,000 miles and everything's hunky dory. Well, there's a lot of people who live in those places, and they're not going to be inviting hundreds of millions of people because there isn't room for them. And B, it's just a different place 1,000 miles north, and you cannot replicate the ports. You can't replicate the growing seasons, et cetera, et cetera.
Yeah, well, that's a great point. There's another problem here. It's the same with temperature. These figures don't immediately capture our intuition. So when you talk about a 3 to 4 foot sea level rise, I think most people picture standing on the beach at low tide and suddenly have that beach look like it does at high tide. And that's more or less the whole story, right? This picture of inundation into cities, rendering them or parts of them uninhabitable, that is counterintuitive. Perhaps you can massage that part of the brain for a moment.
Sure. Well, again, we're talking about a change on top of the average. So it isn't changing low tide to high tide. It's adding another high tide on top of high tide. And there are several reasons that matter. First of all, we've all been to beaches. So beaches tend to be flat, relatively flat. So a small amount of sea level rise wipes out the beach, right? I mean, because if you go in, a few hundred feet to most major beaches, those are heavily populated areas. So, we are literally going to lose all the major beaches. And already now, people may not know this, the federal government spends $100 million a year replenishing the sand on U.S. beaches.
But then why isn't the worst case scenario there that, all of these beach communities lose their t-shirt shops and their tattoo parlors and some restaurants and whatever else and the parking lots and perhaps the coastal highway they have running along the beach, and they just have to pull everything back a few hundred yards and start over.
Right. So now we're talking about what's the average sea level in the area. Let me get to. I'm going to come to storm surge because people should also have in their mind Superstorm Sandy, which is you're now imagine a world, or let's go straight there first. We'll come back to your point. So imagine storm surge on top of high tide, on top of sea level rise, which of course is what happened with Sandy. Right? Sandy hit at the worst possible time near a high tide, and the counterclockwise rotating winds push a wall of water against southern Long Island and the Jersey coast and up where Manhattan is, right? And that same thing happened, by the way. This is why you get the storm surges on the right hand or west side of the storm. That's what happened when Katrina hit New Orleans. Everybody, 50 to 100 miles to the west, which included my brother, had this wall of water that had been swept in by this hurricane, shoved on land. And that's what Superstorm Sandy was. Superstorm Sandy was the largest hurricane ever above North Carolina in the United States. And it swept in a storm surge on top of high tide, on top of what sea level rise we already had. And it was the second most destructive storm, and everybody knows, has images of what happened. Now, because of the sea level rise we had as of Sandy, NOAA issued a study saying that the storm surge we had in Sandy had already become twice as frequent just because of 8 inches of sea level rise. And NOAA has said, now leap into the second half of this century. As you add another foot of sea level rise to 2 feet, to 3 feet, you're now going to turn the Superstorm Sandy storm surge into an every other year event. So that's, again, this gets to the point that what we're doing is dramatically changing the probability of the most extreme events. And it's the most extreme events that are the most devastating to us, whether it's a 5-year drought, whether it is a Superstorm Sandy. These are the events we have to worry about. Now, there's a second issue is, do I just live in a place which is, a foot above sea level rise on average? If you've ever been down to, the Everglades, right? I mean, they're the Everglades because they're right there at sea level rise, basically. You look at Miami, Google a picture of Miami. It's sitting there right on the sea level. Right at sea level. So if you add 2 feet, 3 feet, the entire area is under, half the area is under water all the time. And then during high tide, another quarter is, and then the super high tide, which are called the king tides, which we're coming up on. The king tides happen in the fall. And if people have read stories about Miami, they already know that it gets flooding in large parts of Miami on perfectly clear days, simply because Miami has the misfortune of being built on limestone. In fact, all of South Florida does. It's why you can't protect Miami with the same type of levees or ocean guards the way that the Netherlands do, because the water seeps directly through the limestone. You have to picture limestone is like Swiss cheese. If people who've watched Years of Living Dangerously, we our second episode with Jack Black of this season, he talks to the mayor of Miami. He talks to an expert who shows him a picture of limestone. But if you imagine your city built on the rock equivalent of Swiss cheese, then it doesn't matter if what you build protecting your city, the water comes underneath, and that's what's been going on. And of course, it's salt water. It's been infiltrating into the water system, so they've had to put in massive pumping systems. So the point is that many places are simply so low lying that Bangladesh, the bottom third of Bangladesh, for instance, those people simply are going to have to leave. And a rich country like the U.S., again, when you say, "Oh, let's retreat a few miles," well, we don't, of course, that's going to cost hundreds of billions of dollars, but we're a rich country. Many places in the world have no such luxury.
Right. And that doesn't, retreating a few miles doesn't deal with the dust bowlification at our backs as we come inland.
Right. And one point on dust bowlification I like to mention: the word desert, the normal adaptation over last 10,000 years, even though the globe's climate has been generally slow changing, obviously we've had places like the U.S. Southwest which have had big droughts. Other places have had long droughts. What happens is the normal response to a massive change in climate is abandonment. That's why the word desert has the same root as to desert a place. Look up the etymology of the word desert. It means abandoned place. And by the way, if you look up the etymology of the word river, it is the same as the etymology of the word rival. River is a place people fought over. And guess what what they fight? They say in the Southwest, whiskey's for drinking, water's for fighting. We have a pact with Mexico, right, that shares the Colorado River. The Colorado River Compact distributes water to different states and then the end to Mexico. Well, that compact happened to have been written during the wettest decade of the past 200 years. So we already have countries and states that are beginning to have serious conflict. And literally we ain't seen nothing yet if we allow the warming we've seen to continue unabated for several more decades. Then we're going to be having fights over water, fights over arable land, fights over where we relocate hundreds of millions of people.
I guess so. Let's bound our expectations here with the best case scenario and the worst case scenario. What at this point, given what we have done and haven't done, is the best case scenario going forward?
Sure, and this is one of my subjects I've spent a great deal of time thinking about. In fact, the book, The Climate Change, What Everyone Needs to Know book from Oxford, has a whole chapter. What's the best case? What's the worst case? So, every year we dawdle, the best case gets worse, right? We've let because one of the most important things, and this gets to both the best and worst case, is that generally speaking, climate changes are irreversible. They're irreversible over a time frame of 1,000 years. So if sea levels are rising, they're not going to be falling for 1,000 years. And one of the easiest ways to think about this is imagine you're in a room temperature 75 degrees and you have an ice cube and you put the ice cube on the table, right? It's going to melt. Now you'd say, what do I have to do to get that puddle of water to refreeze? Well, the answer is I'm going to have to lower the temperature dramatically for a really long period of time. So the point is, melting and freezing are not simply easily reversible processes.
Highly asymmetric. Yep.
They're asymmetric, exactly. So once you start Greenland and Antarctica melting, it becomes harder and harder to stop them. So the best case scenario would be if the nations of the world all followed through on their pledge in the famous Paris Climate Agreement of December 2015. In December 2015, all the nations of the world, over 190, got together to finally say, rich country and poor country, here's what we're going to do to get off the business as usual path. Here's what we're going to do, in fact, to reduce emissions, most countries. And that's what we're just going to commit to in the 2025 to 2030 timeframe. We are pledging in this unanimous agreement to our understanding that if we're going to avoid catastrophe, we need to keep total warming, and the quote is well below 2 degrees Celsius, which is well below 3.6 degrees Fahrenheit. And that means we're going to have to take the entire world's emissions to zero sometime in the second half of the century. And that means we're going to have to keep ratcheting down our targets every, let's say, 5 years. So we're going to have to keep coming back and keep toughening up our requirement. And if we can do that, we can keep warming below 2 degrees Celsius. And therefore, we're going to avoid some of the worst case scenarios. And the stuff we can't avoid is at least going to happen a lot slower. So that'll give us, instead of happening in 50 years, it might happen in 200 years. And obviously, that would give us a lot more time to prepare. And now, many scientists, if you talk to them today, they would say, well, can you guarantee me that we're not going to lose the West Antarctic ice sheet if we kept warming below 2 degrees Celsius? And they would say, I can't guarantee it. It is clear from the paleoclimate record that as you approach, in the paleoclimate record, if you get that 2 degrees Celsius warming or more, you are talking about periods of the Earth's history where sea levels were 50 to 100 feet higher. Now, again, I want to be crystal clear. This 50 to 100 feet doesn't happen overnight. It's just when you cross the warming threshold, you've made it irreversible. And even if it takes 200 years to go up 100 feet, then we're talking about staggering rates of sea level rise, right? We're talking about a rate of sea level rise, and I did a recent post on this because that leaked national climate assessment you may have read about said that by the end of the century, on the current path we're on, sea levels will be rising a foot a decade. Now, I just want you to visualize the world near the end of the century. Sea levels are 3 or 4, 5 feet higher, and they're rising a foot a decade. And you know that they're going to rise a foot a decade. So now, how do I plan? How much land do I abandon, knowing that if I were to defend the land as it were right now, it'll be inundated in 20 years? How do I design a port city? How do I design a sewage system? Where am I going to put the sewage that I was dumping into the ocean? Sewage treatment plants, right? They're incredibly expensive. They're huge, difficult to move. So, we're creating, for a rich country like the United States, an endless series of catastrophes that, instead of happening rarely and not at the same time, are happening commonly at the same time. So in other words, when you look at how the world deals with a superstorm or a drought, well, oftentimes the world gets together, right? And we all help these people. But if you're having every country in the world dealing with sea level rise and superstorms and droughts at the same time, well, the U.S. isn't going to be offering help to Haiti or Bangladesh. We're going to be dealing with a mega drought in California. we're going to be dealing with Superstorm Sandys every other year, right? So we've got plenty to spend our own money on. So this is the reason why climate scientists have been getting more and more alarmed and more dire. It's not because I can tell you exactly what's going to happen in 50 years. It's just I can tell you if we keep on the current path, 50 years is going to be a world so untenable, and 100 years, you've basically rendered large parts of the planet simply uninhabitable. And this is what we're leaving our children and grandchildren, despite the fact that scientists have warned us for a quarter century, and also despite the fact, and I would hate to leave this conversation without at least mentioning the fact that we've had this clean energy revolution. So that in the last 5 years, the world of clean energy and the solutions to global warming have literally changed night and day, so that now you can absolutely imagine the world replacing fossil fuels with clean energy over a period of a few decades. And therefore, that's sort of what makes the best case scenario plausible, right? We do have an alternative. It isn't expensive. Every economic analysis, by the way, says that you would not notice the change on economic growth from the clean energy path to the current dirty energy path. And that's without even counting the avoided catastrophes.
So, Joe, I want to talk about the politics for a minute. I want to talk about how the science has become hostage to politics. As I'm listening to everything you've said, I can't help but recall that we now have a president who says things like, or rather tweets things like, climate change is a hoax invented by the Chinese to destroy our manufacturing base. And the consequences of having the most powerful person in the world think that out loud, whether in fact he actually thinks that, just strike me as enormous and altogether terrible. So I just want to ask you about how you perceive the politics here and whether the skepticism that's often expressed about climate change is in fact true skepticism, or is it feigned in the service of some other agenda? I mean, this is now this lawsuit against ExxonMobil, which was recently in the news. They seem to have known for some decades, I think, what is going on, but then they've misrepresented their own data in these advertorials in the New York Times. How do you perceive the politics here?
Yeah. So that is a whole podcast in and of itself. Let's try to I'll try to focus on the key points. So um, why haven't we acted, given that there's in the real there's 97% of climate scientists. I'm not going to say that they would agree word for word with everything I say, but fundamentally what I've laid out is commonly known among the scientific community, and is commonly known among the political class of every major country.
Actually, Joe, I want to ask you about that figure, 97%, because many climate change skeptics say that has just been made up. Perhaps you can say something about where that comes from and who are the 3% of scientists who climate change skeptics are relying upon as a counterpoint here.
Well, the 97% number comes from what is now half dozen or more peer-reviewed studies of the literature, and basically asking the question: how many people in the climate literature actively dispute the overall what's called consensus. I'm not a big fan of the word consensus because in popular parlance, consensus means consensus of opinion, whereas in this case, it is a consensus of scientists who spent their entire lives studying an issue, and this is their conclusion of what the peer-reviewed literature says. So yes, so many of these studies have shown that there is this roughly 97%. Some studies show a little more, some studies a little less, but we're talking in the high 90s of scientists who publish in the climate arena agree with the essential points that the climate is changing and that humans are the primary cause. if you want to read the full scientific consensus, then you would, read the summaries of the Intergovernmental Panel on Climate Change reports, but they're not easy to read. Now, it's also the case that the few percent of people who dispute the consensus and who are also scientists who publish in this arena tend to be the ones who haven't published a lot recently, and would not get high ratings on the how often their work is cited and all that. So I put it to people this way: if I told you that you had a unknown tumor, I there was something unknown on the X-ray of your pancreas, you would try to find the best pancreas doctor in the world, and you would certainly ask around to who are the best, and you'd get an opinion, and then maybe if you didn't like it or whatever, you get a second opinion. But no one goes around when you're diagnosed with a serious problem. You don't go around shopping for somebody who isn't highly respected in the field to tell you it's no big deal. And you don't treat your kid that way. And not only that, you don't if your kid has cancer, you take him to a pediatric cancer specialist, right? You don't take him to a dentist. So yes, we personally, in our own lives, when a problem is in front of us, we try to find the world's expert or a specialist. And the deniers and this disinformation campaign that ExxonMobil helped start is all built around hanging your entire future of you and your family and billions of people on a tiny minority of people who are not highly regarded in the field.
I love that analogy that if something is directly threatening your life or your child's life, your MO at that moment is not to find the one person who will tell you there's nothing wrong. You actually want the most valid information you can get your hands on. And when you hear that 97% of the experts who spent their lives focusing on that topic are pointing one way, that's all you need to know, assuming you are not the lone genius in a generation who has some deeper insight on that topic than 97% of the field. I want to throw some more red meat to the skeptics here because really the point of this conversation is to reach some people who are mistaken about the state of the science here. And many people seem to think that the climate change deniers are on fairly firm ground in saying that the predictions about climate change, going back decades, have been totally overblown. Is this true in any sense?
No, no, and in fact, as is often the case, the reverse is true. I think, and in writing, the climate change, what everyone needs to know book, which is it's in Q&A format. You have it. It's 90 questions and answers. I reviewed the entire literature. I talked to lots of scientists. I talked to lots of scientists for my for Climate Progress, but I was able to get the latest. And if you look at the state of predictions, let's say 2 or 3 decades ago versus what's happening now, I would say there are two classes. There's the class of the predictions were basically in the ballpark, and then there were the predictions that underestimated what's going on right now. There are really it's exceedingly hard to find a prediction where the scientists over projected what was going to happen. Now the deniers, of course, you can find that 1 in 100 scientists who gets paid by ExxonMobil to write a study saying that this prediction was wrong, right? But that's not accurate. That's just the deniers build their case on dubious science.
Right. I mean, that's a point I should have made a few moments ago. You can always find a few PhDs who will attest to any crazy thing. I mean, this is what Big Tobacco did. This is what the 9/11 Truth cult does. I mean, you can find somebody in some relevant field. You can find paleontologists who are, in fact, fundamentalist Christians who just got their degrees in paleontology to prove the veracity of Genesis. There are scientists or people who are scientists on paper who are fundamentally committed to some kind of ideological advocacy and don't have a scientific bone in their body when you actually drill down on how they're thinking about reality. And this is not at all obvious to the general public.
Yeah, no, and I think that, there's been a war on science for decades. And, some would say the genesis was the tobacco industry, and then that evolved into a whole a cadre of people who are really good at spreading disinformation, and that continues all the way up to the Russian fake news sites. So the people who are good at spreading falsehoods have more tools, and of course they study psychology, and so they understand the best tricks, and they're better at communicating than scientists are, right? Because scientists are not trained to communicate. That's not what science is about. Science is about, this experimental method and a very analytical approach. Communications is a very different skill. And it's no surprise that professional disinformers, whether it's the KGB or the people hired by the tobacco companies or the oil companies, are good at it. And that's why, by the way, when I talk to somebody and if they throw one of these myths at me, it's not their fault, right? I mean, these myths have been tested over time and repeated endlessly, and they get the echo chamber of the right wing media. So, unless you follow this closely or get your news from the real sources of news, you're going to have heard these. And not only will you've heard these, you'll have heard them more than once, and you'll never have heard them debunked. So yeah, there's this 1/3 of people, let's call them the current diehard Trump supporters, who have an alternative set of facts. And the thing is that we don't teach science very well in this country, and there's not a lot of great scientific literacy. Most of these science reporters have been fired in the past 10 years as the media had consolidated and focused on the Kardashians and the Trumps and the things that get clicks. So most people don't understand how the scientific method is different from other ways at coming to the truth. And it matters when 97% of scientists agree on something, because anyone who could prove the contrary would become instantly famous and win a Nobel Prize. The science is an adversarial world where all scientists are skeptics. So that's how science, in some sense, polices itself. It isn't hard to come on from the outside and make up a bunch of crap and have it sound persuasive. That was the essence of rhetoric. And I don't know if I did a whole other book called Language Intelligence, where I talk about, the secrets of the world's greatest communicators and the development of rhetoric and how people learned how to win arguments without the facts and through appealing to the emotions, the figures of speech. That talent, which Trump is an expert at, is a powerful tool, particularly in the wrong hands, because the fact is that human beings have all these shortcuts for making decisions. That was the great, work of the behavioral economists and thinking fast and slow, the work of Kahneman, who won the Nobel Prize in economics for this work, basically saying that we use our intuition to make most of our decisions, and then we find the facts that then back up the decision we make. And our intuition is built around a lot of shortcuts, which are emotional or which often work. Like, I'm going to find out who somebody I agree with 90% of the time. What do they think? Right? So I like Fox News. What does Fox News say about climate change? Okay, it's perfectly reasonable for most people to say, I don't have the time to become an expert on climate change, so I'm going to find a shortcut. It's like, which movies do I go to? I find a movie reviewer who tends to like the movies I like. So we have all these mental shortcuts, but they are shortcuts from reasoning. And they're designed because we don't want to think about most stuff because we don't have the time.
Is there anything that those of us who are worried about climate change have said or done that has been dishonest or counterproductive? I'm thinking of things like ClimateGate. What was ClimateGate and how did that affect the public perception of this issue?
Well, let me start by saying that, look, scientists, as I said before, not the world's greatest communicators, nor were they trained to be. There used to be a whole profession that communicated things like science to the public, and we called them journalists. And they're science journalists or climate journalists. As a profession, they don't really, exist anymore. We're just have all political reporters and popular reporters covering subjects like this. And so, scientists have had to learn how to communicate in this era where really everyone is their own journalist. That's why I started Climate Progress. Ultimately, is my frustration at writing a letter to the editor or an op-ed to the New York Times, and that whole process. Um, Simultaneously, we're dealing with a world where emails become public, and I think it's safe to say that anybody who's 10 years ago and maybe even now whose entirety of emails got exposed would spend a lot of time explaining all their shorthand and their in jokes and all that sort of stuff. At the end of the day, the hacked emails were the subject of 6 or 7 investigations and found that there was no there. I will say that we never found out the source of the hacking, but in the light of recent events, I think the most likely scenario is Russia. We obviously they're expert at hacking and at distributing information in a way to have maximal impact. Russia has never liked climate action because they are a resource intensive economy with huge amounts of oil and gas. And of course, they think that they like the Arctic melting so they can drill more in the Arctic. But so, I think that, yes, there have been mistakes made, but I don't want to shift the blame to people who are doing the best they can trying to warn the public. Whereas it is the people out there spreading disinformation or ignoring the overwhelming scientific understanding who are, doing the real harm.
So, what about Al Gore and his first film, An Inconvenient Truth? How does that messaging look in hindsight?
Well, this is something I've written a great deal about. I've looked at all the social science on it and all the polling. Fundamentally, that movie was an inconvenient truth, and it came out right contemporaneous, around the same time, a little before the fourth assessment of all the science by the Intergovernmental Panel on Climate Change. So it created a moment where people really started talking about climate change, and the media started covering it, and public opinion became more. In the direction of this is a serious problem, we need to take action. And I know some people like to say that somehow the issue got politicized, but the fact is that when you look at the polling, that's not the case. And the public response to simply more media coverage and more attention was naturally this is a bigger deal than I thought, and we should do something about it. It wasn't until much later, frankly, until Barack Obama and people should remember back in 2008, the Republican candidate for president, John McCain, was a longtime advocate for action on climate change, who actually ran on a platform of doing a so-called cap and trade bill to set a price on carbon pollution. It was really only after Obama won and there became a realistic chance that we might take action on climate change, and the U.S. House of Representatives passed a climate bill in June of 2009, that you saw the massive amount of money from the fossil fuel industry and from Koch brothers and others really swell up to spread disinformation and push back and generate thousands of calls to Congress and all that to slow it down and ultimately stop it, which they did do. But again, and then the media coverage went away, and when the media stops covering a subject, it's quite natural for the public to put it lower on the priority scale. And so it really was only in the last few years, with Hurricane Sandy, with Barack Obama in his second term, really talking more about climate change, with the Pope's encyclical, a very important document in which the Pope explained how immoral it is for us to basically destroy the future that we're supposed to leave to our children, and not let them enjoy the kinds of wealth and benefits that we get from the environment. And as a result, there's been this second wave now of concerted public interest. And if you look at the polling, it's clear the public's desire for action, understanding of climate change, has swung back towards a very significant movement.
Right. I want to focus on a word you just used there, wealth, because there's a perception that a response to this problem and any of the proffered solutions will be extremely costly, and that timing our response inappropriately, which is to say, responding too early before the necessary technology is in place, could cost us trillions of dollars, or untold billions of dollars, and money translates into loss of life if you want to run those calculations. And now I'm just turning the conversation towards solutions. I'd like you to talk about the solutions here, starting with things like carbon tax and then moving into the clean tech industry. But in addressing those options, talk about the cost and the sacrifice in wealth to the degree that there is one and that we can quantify it.
Yes, and obviously this is a subject that has been a great debate about, and those who don't want to take action try to gin up their studies to show all sorts of things. The bottom line is two or threefold. The first and foremost thing to remember is that the greatest destruction of wealth is going to come from doing nothing on climate change, because trillions of dollars of wealth are sitting on our coastlines around the world. There's well over $1 trillion worth of wealth just on U.S. coastlines. In fact, there's $1.2 trillion in wealth that actually gets you and I, the taxpayers, are basically insuring through the National Flood Insurance Program, and that means we're the insurer, that no one else insures flood insurance but the federal government, and hence the U.S. taxpayer. So we are headed towards, by all estimate, the loss of trillions and trillions of dollars of wealth, and trillions of dollars that are going to have to be spent on adaptation. How do you protect as you pull back from the seas? So and your agricultural base, and things we've talked about earlier. So concern one is that doing nothing isn't an option. Doing nothing, is going to really wreak havoc on on the United States and the world for hundreds of years. As for the cost, and this is something I studied a great deal, and I was fortunate to help run the Office of Energy Efficiency and Renewable Energy back in the 90s, when we were ramping up, or attempting to ramp up investment on solar power, wind power, energy efficiency, even LED lighting, advanced batteries, hybrid cars, plug-in hybrids, all those things that are now some of which has just transformed the marketplace. As I knew, and those of us who were working on it knew it would do. Every single study that has been done, by a credible independent source, shows that climate action, even strong climate action, does not have a substantial net effect on growth. We're talking about like 0.1% per year. Literally, if I gave you the plot of growth with climate action and growth without it, you wouldn't be able to see the difference. And the reason is fairly simple to understand. Right now, uh, the energy infrastructure, the amount of money the world spends on energy infrastructure, particularly the wrong kind, the dirty, polluting, inefficient kind. Let's say that's like $1 trillion a year, in a global economy, which is, I haven't checked recently, 70 trillion or whatever it is. In order to avoid catastrophic climate change, you have to take that 1 trillion that was going towards the dirty, inefficient stuff and put it on renewable, efficient stuff. And then you have to also, because we've dawdled, frankly, for 25 years, we're going to have to add, another trillion a year in clean energy investment. And so we're really talking about shifting investment. And we're actually talking about shifting investment into technologies that have many other benefits. And I go through those in the books. But first and foremost, the most obvious benefit is clean air. And literally millions of people die around the world from dirty air. So there's all these ancillary benefits from stopping pollution that are kind of obvious. And that actually gets to one part of your question: is delay a good thing? And for over a decade, the International Energy Agency has kept coming out and saying delay is really costly. Because why? We're spending all this money on infrastructure that we're going to have to shut down prematurely because it's dirty and polluting. And so rather than taking that money and investing it in the right stuff in the first place, we're investing in the wrong stuff. Eventually, we're going to have to basically prematurely shut that stuff down and replace it with clean energy stuff. It is true that let's say 20 years ago or 15 years ago, renewables, electric cars were boutique, expensive items, but that has completely changed in the last 10 or 15 years. And right now, the cheapest form of new power generation in the world in many countries is solar, and in many other countries, it's wind. And so the net cost differential for developing around clean energy and developing around dirty energy is virtually nothing. And in some cases, it's cheaper because, as people know, many in the developing world have skipped over all the landlines, all the infrastructure that we had for the old dedicated landline services, and just use cell phones. And the same opportunity arises in, there are 1 billion people who live without electricity in this world. Now, if you wanted to give them the old style power, you'd build a bunch of central station power plants, and then you'd hook up a huge power grid with transformers and all that stuff. Or that's the old way. The new way is the distributed way, where you simply put solar panels and batteries near where people live. And of course, much of the developed world obviously lives in places that are very sunny, whether we're talking Africa or India or China or Southeast Asia, so or parts of South America. So the future really is skipping the dirty, polluting, infrastructure intensive energy path and going straight to the clean energy path. That generally that does require some help from other countries. That was one of the things that have come out of the international negotiations, is the rich countries would help the poorer countries leapfrog directly into clean energy. In the case of China, which had already made a massive investment in coal, and if you have been to China or you've read about it, then devastating amounts of urban pollution. And 10 years ago, the 10 dirtiest cities in the world were, eight of them were in China. Now, five of them are, of the dirtiest 20 are in China, and 13 are in India, because India had been starting a coal-based growth the same way China has. But China woke up to the reality that they were poisoning their own kids and ruining their climate, and people couldn't go outdoors. You couldn't see the sun. So China, in the last several years, has made a massive investment in clean energy, and really coal consumption has started to decline. And many countries are looking at China and saying, do we want to, go through the route of destroy, polluting all our cities, only to have to shut down those plants the way China is already doing it, or can there be finance capital made available? And that, by the way, if you see the sequel to Inconvenient Truth, the Vice President Gore has the new An Inconvenient Sequel. One of the points of that is that during the Paris negotiations in December 2015, the poor countries, particularly India, said, we would be willing to forego coal, but we need help bringing down the expensive, financing costs for this, what is for them a new technology that has high interest rates, like 13%. And people need to understand that, to build a power plant, which might cost billions of dollars, you need to get financing. And that financing, the interest rate, is going to depend on how well known this technology is, and how how good your credit is. So in the U.S., we've been doing solar for a long time, and the technology, doesn't have any moving parts. It lasts a long time. It's now possible to get very low cost financing where you don't even have to put any money up front. In India, which obviously is a country that doesn't have as a reliable market as we do, and solar is newer, interest rates are higher. And this is where the international community, and there's some scenes with Al Gore helping to raise finance capital, the World Bank saying, we will make available billions of dollars in finance capital so that you can go straight to clean energy. And a lot of the banks in the world have stopped or curtailed or investment in coal plants, because they don't think those coal plants are going to be able to generate profits to pay them back over the next 30 years. So we are in the midst of this transition, and that means a lot of old arguments that you've heard that might have been true 10 years ago. The technology, the financing, everything is changing so fast that it really isn't true. Everything is in flux. So, the bottom line is the clean technology is now here. And, particularly for the electric grid, the next generation for transportation, the two big generators of pollution are the electric grid and the transportation system. Cleaning up the electric grid is now, we know how to do it. Very straightforward. Many countries are shifting towards very deep penetration of renewables. Germany hit a peak of like 88% renewables last year, I think, on one day. Denmark, over 100%. Some states are seeing 20, 30%. We have a commitment among the largest economy in the U.S., California, to go towards very deep renewables penetration. So you're starting to see that transformation in the electric grid. And the next thing is, what do we do in the transportation sector? And here is where electrification comes in, because if you make the grid carbon free, then running your transportation system on electricity will also be carbon free. And the good news here is this just unbelievable revolution in battery costs, which have come down like 75% since 2010, and they are projected to come down another 75% in the next couple of decades. So the battery cost revolution will enable storage for variable solar and wind, and we're starting to see more of that. and the cheaper batteries are what have enabled this revolution of electric cars and the introduction of electric cars that cost under $40,000 and have more than a 200-mile range. And if you get tax credits, they're going to cost closer to $35,000. And that's what the Tesla Model 3 was. It had, when Elon Musk announced it, put it on pre-sales. Pre-sales announcement last spring of 2016. That car had the biggest pre-sales of any car in history. In over a course of a weekend, it had 300,000 pre-sales. 300,000 people plunked down $1,000, and
Actually, it's even more hyperbolic than that. If you count all of those down payments as actual sales, I mean, obviously people can decline to buy the car, but if a significant percentage of the people who put their down payment down to buy the car actually buy the car, there is no product in human history, including the iPhone, that sold with that kind of velocity.
no, absolutely. We're talking about, in that case, 300,000 times, $30,000. So,
Something like $10 billion in 24 hours.
right. And now, as of, a couple of weeks ago, I'm sure people saw the news of Tesla rolled out its first Model 3s to customers. And as of now, they have 500,000 pre-sales, and they are ramping up production. The big question for Elon Musk is can he meet the kind of production that a major auto company meets? And that remains to be seen. But because of Elon Musk and his investment and the work that he's done bringing down the cost of electric cars and batteries, every other major manufacturer has already made a major shift towards electric cars. Ford Motor Company, General Motors, the German car companies, even the Japanese car companies, who by the way, Nissan had the number one selling, has the number one selling still today in total sales electric car, the Nissan Leaf, and the Chinese, realizing that this is the future and have decided they want to be the world leader in electric cars and batteries, just the way they became the world leader in wind and solar. And their decision to be the world leader in wind and solar is what helped bring the costs down so much. And you are seeing, 2 years ago, China passed the U.S. in total electric cars on the road, and now they are accelerating well past us. They have much bigger subsidies. Many of those countries, like China, are motivated not just by the opportunity in the long term to reduce greenhouse gas emissions, but by the fact that their cities' air is unbreathable. Right? And there's only two solutions to unbreathable air in the city. You have to stop tailpipe emissions from cars, and you have to stop burning so much coal in your grid. So that's the transformation that we're going to see over the next 10 or 20 years. And it's one of the reasons why, in Paris in December 2015, for the first time, major developing countries like China made serious commitments to restrain or cap their total emissions. And in China's case, to double the amount of carbon-free electricity they deployed by the year 2030. So we're now in the inflection point. We're past the inflection point for solar and wind. We're now in the heart of the S curve that people draw when you're really on exponential growth. We're at the beginning of the S curve on electric cars and batteries, and the synergy of those two is going to transform the entire energy system of the planet over the next 10 to 15 years. And by the early 2020s, early to mid 2020s, by all projections, electric cars will be equal or cheaper in their initial cost than gasoline cars, and they will have much lower maintenance and fueling costs. I mean, like 1/4, even running on pollution-free power. So we are I do get excited talking about this because, when I was at the Department of Energy, we knew this day would come. We didn't know when. We put a lot of money into it, and ultimately businesses in other countries did too. But this has been a long time coming, and it is now here. This is the clean energy revolution, and it's happening in real time, and it's every way as comparable to the industrial revolution.
Well, so in light of that, and that's perhaps the one hopeful note struck in now 2 hours of conversation, what's the place of nuclear here? Because many people are putting their hopes in cleaner, more stable versions of nuclear. Is nuclear necessary or not?
Well, that is a very good question. Nuclear, right now, over half of US nuclear plants, existing nuclear plants, are bleeding cash. Did a post on that. That's based on Bloomberg New Energy Finance analysis, but nobody disputes it. The nuclear plants cannot compete with cheap natural gas as an average price, and they cannot compete with solar and wind, whose marginal cost, once they're up and running, is zero, right? You don't burn any fuel to keep the solar and wind going. So right now, they're not economically competitive. And by the way, which means you can imagine if an existing plant, which has already been bought and paid for, can't make money, that spending $10 billion to build a new plant is something nobody wants to do. And the as a result, virtually all of the projected new plants have failed because their costs have been going up. The projected costs have been going up, and their projected future profits have been going down. So you literally can't. You just don't see in market-based economies many new nuclear plants built. Their price tag is the total price tag for twin nuclear plants in this country and most recently in Egypt is like 20 to 25 billion dollars. It's just not an outlay that boards of directors are going to make. So there is a big investment to try to develop smaller, more modular, and hopefully cheaper plants. But right now, I'm by the way, and I'm not someone who thinks we should shut down existing plants. If we had a reasonable carbon price, then existing plants would keep running because they would be cheaper than natural gas, even the cheap natural gas. The problem is that we've been unable to get a carbon price passed in this country, and if we did, if we had the right carbon price, if the price of carbon reflected the actual damage that carbon does to the world, then we wouldn't need a bunch of other policies, right? The market would just figure out what is the cheapest thing to deploy, and it would deploy it.
Joe, that's a huge point. I just want you to emphasize again because we don't price carbon, you have these industries that are polluting and causing great harm. Forget about climate change for the moment. Just come back to the clean air point you made. I mean, you could run this whole argument through talking about nothing but clean air versus dirty air and the epidemiological and quality of life consequences. We have industries that are polluting the environment and harming human health, and they're not forced to pay any compensation for that. And so this represents a massive subsidy. People complain about Elon Musk's businesses getting, subsidized with tax credits, but there has been a massive subsidy for decades and decades simply because we have no price on carbon.
Sure. Well, the annual subsidies direct through the tax code to the petroleum industry is something like $4 or $5 billion a year. And by the way, we've always subsidized new industry. The federal government created the nuclear industry, right? And the federal government's research and development was critical to the breakthroughs that allowed fracked gas and oil. So you're absolutely correct. If you actually price the human health costs, just the human health costs of fossil fuels, we're talking trillions of dollars. And then if you throw in the clear damage that we are in the process of doing to our coastal areas and et cetera, we're talking $1 trillion again. So, if we had if all of the pollutants that we release were priced, if someone who emitted those had to pay for the damage they were doing, then the market would figure out ahead of time what the right amount of clean energy and dirty energy would be, and it would be a lot less dirty energy. So
Which Joe, we should point out that this is a classically libertarian description of what to do. I mean, it's really an amazing irony that the people who seem to be against doing anything about climate change, I don't know what the percentage actually is, but in my experience, a very high percentage of these people consider themselves libertarians. But the core philosophy of libertarianism is that you have to price in all the benefits and harms of any given economic behavior. And if the stuff that's coming out of your smokestack is going directly into my lungs, in a libertarian system, a true libertarian system, you would have to compensate me for that. That is, in fact, the price of your activity. And if you can't compensate me for that, you can't do it.
well, yes, and I don't like to spend a lot of time defending cap and trade per se. It's basically you put a price on a pollutant, you create a cap, and you shrink that cap over time, but you allow the companies that emit the pollution to trade the permits among themselves, so the people who are most efficient at reducing pollution reduce it first. And this was an idea invented by economists and generally embraced by moderate, well, I don't want to use the word moderate because we're talking Ronald Reagan. It was Ronald Reagan who actually used the cap and trade system to phase out lead in gasoline in the 1980s. And then it was George Herbert Walker Bush in 1990 who used the cap and trade system to cut sulfur dioxide emissions, which were acid rain. And this worked unbelievably well, because when is the last time you heard people talk about acid rain? We've made tremendous progress there. So the fact, putting a price on a pollutant, until was considered to be the most centrist, business friendly, I don't want to say Republican friendly, but that's just it's just the fact of the matter. And it's only because we have a national Republican Party. There are people like Arnold Schwarzenegger and Michael Bloomberg and many people around the country of all stripes who have been doing the right thing. But at the national level, where things are driven by the money of the fossil fuel industry and the Koch brothers, they have created this climate where you can't even adopt the most efficient and economist and Republican originated means of cost effectively reducing pollution. So there's a lot of talk now, a lot of movement to try to get a price on carbon. It's obviously not going to happen while Donald Trump is president, but most other countries have embraced this. Europe embraced a cap and trade system. China started testing a cap and trade system a few years ago, and their expectation is by the end of this year, they will have a national cap and trade system for coal power and a few other sources of carbon pollution. So it is ironic, but not unusual, that U.S. invents something and then we don't adopt it. Uh, I think at the end of the day, I think first and foremost, what I try to say to people, and I say in the book, is everyone needs to become educated on climate change, because it is simply climate change, and our response to it is going to change the world over the next 25 years as much as the internet did in the last 25 years. And there will be two kinds of people: the smart money, the people who know what's happening and who's going to happen, and the people who don't. Some of those people, the smart money, are starting to get out of coastal property because they understand that market's going to crash. And smart high school students and college students understand that there are many areas that are going to be seeing a lot of job growth, whether it's clean energy or building levees the way the Dutch do, or clean air or clean water or sustainable agriculture. Knowing how the future is going to play out is very valuable information. And so I tell people, doesn't whatever your politics is, I just urge you to get informed because we do have a very good idea of what is going to happen over the next 25 years, and that's why I wrote the climate change. What everyone needs to know. It's not as you read it, so there's not any politics in the book. It's all in Q&A format. I cite the literature. I cite the major reports if people want to go get those. It's written for general public, and I just think that those of us who do understand what's happening, have some moral obligation to try to inform the public so they can make good decisions. Whether that's a good decision at a personal level, or if they get motivated enough, maybe they become more active in their community or in politics. But the goal is, here is the best information we have. You now decide what you want to do about it.
Well, Joe, I'm mindful of your time here. I know I promised I would let you go 7 minutes ago, and so I've, in fact, reneged on that promise. But I just want to give you a few rapid-fire questions here that I've gotten from Twitter. Much of the questions here that I've gotten, and again, I got over 1,000 we've addressed already in our conversation, but there's a few that I'd like to touch on, and then we'll be done. So it's been said that Trump's pulling us out of the Paris Climate Accord was more or less meaningless because the accord was more or less meaningless. What has been the effect there? And you might just extend that to the effect of Trump himself being president and appointing people like Scott Pruitt to run the EPA. What's been happening in the last 6 months?
Well, there's no rapid fire answer. I'll do the best I can. The Paris Climate Agreement was transformation. It was a total game changer. It was the first time all the developing countries came to the table with pledges to take specific actions, and the largest, China, committed to actually cap pollution. They committed to cap pollution by 2030, but they are way early, and it appears that they're in the process of plateauing emissions now. And so, and as someone who went to Paris and was there, I could tell you just the enthusiasm, not just among the delegates, but there were so many subnational groups, businesses, cities, states, regions, who made very strong pledges and commitments to action. And so, no, Paris was a total game changer. The pledges that the countries made leading up to Paris represent about a degree, almost 2 degrees Fahrenheit lower temperature than would have been, and really got us off, for the time being, the worst case scenario. Now, that includes, of course, the U.S., Barack Obama at the time, making a pledge and promising to keep it. So yes, when Trump pulls out and says, we're not going to do any serious action, and not only that, we're going to hire people like Scott Pruitt and Rick Perry so that we can burn more fossil fuels rather than reduce pollution. We'd like to increase it. That is a serious blow, and one of the reasons it's a blow is because we're on a knife's edge. The scientists have been telling us for 25 years, please start taking action. And we've not only ignored them, but we've done the reverse. Emissions have gone up. So we have run out of time for dawdling. Paris was our best, I don't want to say last best hope, but it was our really only best hope for the world to get on a new path. And thankfully, because of Paris, we are on a new path. Global emissions are flattening. But the key thing for everyone to know about Paris is that Paris only required countries to make commitments for what they would do through the year 2025 or 2030. Whereas, as I said earlier in the show, we have to go to zero globally sometime in the second half of the century. So the Paris Treaty begins a process where all the member nations have committed to come back every few years, review how they've done on their pledges, and to make stronger pledges. So you have to keep ratcheting down emissions. So for me, the biggest problem with Trump pulling out isn't so much that he's going to have a big impact on what specifically happens in the 2025 to 2030 time frame. It's that we have to come back again and get all the countries in the world to make a tougher pledge. And if the richest country in the world, and the second biggest polluter says, we're not doing anything, needless to say, it gets hard to get other countries on board. And I would add, by the way, that the fifth biggest polluter of carbon is Russia. And Russia has not ratified the agreement either. And there's every reason to believe that as long as the U.S. doesn't, sign on, that Russia won't either. And that is a serious chunk of emissions.
I'll just give you two more here. And I know this one actually comes from a previous podcast guest, Scott Adams. I don't know if you know him, the cartoonist.
I don't know personally, but I know of his rantings online.
Yeah. So he wants to know how much subjectivity is involved in the climate science as you move from the measurement devices to the climate models. He seems to think, or he's echoing a widespread belief that the modeling is a very inexact science. I mean, so much so that it really doesn't even count as a science because you can just pick whatever model supports your political agenda. How much finessing of the models has been going on, and what sort of peer review or auditing protects us from purely fake science at the level of climate modeling?
I admire your sense of humor that this is a rapid fire question. First of all, this is such one of the standard myths of people who try to create confusion that it's one of the top 10 myths on Skeptical Science's webpage, and those who want the full answer. So yes, Scott Adams, well known for Dilbert. He's not a scientist, and he's a celebrity, and so he doesn't know anything about climate change science. He doesn't know about anything about clean energy solutions. If he's ever talked to a serious number of climate scientists, none of those people have ever been quoted on his website. But he's articulate. He's a good popularizer. He just happens to have decided to join the 3% of people who are out there and trying to cast doubt on the ever strengthening consensus. We use models for everything in life, right? We needed models to figure out how to put 12 men on the moon and how to get them back. And when one of them went awry, we needed models to figure out how to redo everything. Models of gravity, the Earth's atmosphere, and all that stuff. We use models for epidemiology, and we use models for every single drug you take. It's based on modeling statistically what it's going to do in a larger population. And so to cast, and by the way, when the National Hurricane Center says to Houston 3 days ago, or Corpus Christi, you're on track to get hit by a hurricane, we strongly urge you to prepare for it. That's just a model. So it's ridiculous for anybody to say models have no value. We use models using scientific information to make a lot of predictions that we use every day that are life and death. All of the climate models are tested rigorously against what happened in the past and what is happening right now. And when I say the past, there is the recent past of decades, and then there's the paleoclimate, because we actually have hundreds of thousands of years of temperature data going along with, it's possible to know what global temperatures were as well as what global emissions were. So we run it against paleoclimate data. And by and large, the models, as I've said, you asked me this question, if the models overestimated or underestimated climate change. And by and large, they've either got it right or they've underestimated. We certainly have underestimated the rate of ice loss in Greenland and Antarctica, and the ice sheets, and the rate of ice loss in the sea ice of the Arctic. And so that just means, and I think if you were to talk to most climate scientists, they would say there's a very good chance that we've left out some feedback processes that speed things up, because we can only model the stuff that we know. And so when things happen faster than we expected, it just means we didn't model something. So we are constantly refining these models. But the fact is, no, that this question by Dilbert et al. is really something his pointy-headed boss would come up with, and a smart engineer like Dilbert would simply read the literature and look and figure out what's going on.
Spoken like a true fan. Joe, you've been incredibly generous with your time, and this has been everything I hoped it would be as far as being comprehensive and detailed, and it's really been